Alright, so I already cleaned up these boxes for the most part. Like I had my neutrals and my hots separate, but one of the first things you should know about electric is being able to tell the difference between what kind of wire you're looking at. And you usually have what they call hots, grounds, and neutrals. Hots are usually black in your house. They're either black or red or blue. Usually if it's got a color other than green or white, it's a hot. It's safe to assume it's a hot. Neutrals are usually like, they're the wire that lets, when the electricity has been used by the device that you have it plugged into, it's what takes the electricity back to the panel so the circuit's complete. That's what makes it work. Neutrals are almost always white or some sort of neutral color that isn't black. You shouldn't be seeing gray wires in your house because that's usually for 277. That's a much higher voltage. Like your house is usually 120, so it's usually almost always going to be white. If it's an old house, you might see a situation where you either have just two black wires and one's coming into the device and outside of it. Usually if you're seeing that as the case, you try to, it's a little trickier to check that, check which one's a hot and which one's not. You'd usually have to use a ticker, which is like one of these. There's a tracing pin. That will usually give you a good idea, but what you want to do when you're in a situation like that is to make sure that you label which one's the hot and which one's the neutral. You don't have to get white tape and black tape, all that stuff, but it's good to do something that lets you know that which one's the hot and which one's the neutral. But anyway, I'm going to start off with light switches because they're probably one of the most simple things you can change in your house. Usually you take your black and you put it on the top skirt of your light switch. You make sure you got it the right side up. Black goes in the top, and then you have an additional hot that comes out of the switch. It's not connected to the main circuit because the whole point of this is to interrupt the circuit when you want to do, when you want to turn the lights off, it stops the electricity from coming into the light. So you put your hot on this, and then you send a separate hot to the light, and then from the light you have a neutral that comes back to the box. And I can make a diagram later and show how some of these work on paper, and we can post that with the video. But yeah, so switches are pretty much one of the most simple things you can do. And because we have two switches in here, I've already isolated which switch light goes to which. This one was on this one, so I'm going to start with that. And the tool I'm using here is called a wire stripper. They come in a bunch of different shapes and sizes. I would recommend making sure you get one that has the spring in it because the normal wire strippers are kind of difficult to deal with in my experience. But pretty much when you use a switch, you put a hook on the wire like this. You don't always have to do that if it's a brand new light switch. A lot of times they're making it to where all you have to do is just strip the jacket back a little bit, which is the plastic on the wire that stops you from shocking yourself, and you can just stab it right in there. You don't have to do anything to it. One of these really old ones, you just have to put a hook on it, hook it around that screw, tighten the screw down. Also, a lot of times, especially if you guys have never bought a house before, if you're buying your first house, it's probably going to be an older house, and if it's built in the 70s or earlier, you're just going to have this stuff called cloth wire, and it's famous for being real dirty and real gross. It's you could replace it if you want to, but it's not really worth it because rewiring a house gets really expensive, especially nowadays. But cloth wire, that's usually the one you're running into where it's really hard to tell which one's the neutral and the hot because the jacket has degraded so much that they kind of lose color. I'm just gonna do the same with the hot here. A lot of times you'll also see some questionable wiring decisions in older houses with switches, because sometimes a lot of people will like to strip their jacket back about at a midsection on the wire. They leave it long, strip a midsection, and they hook it on the screw it back down, and then run that little pigtail over to the next one. I personally don't like doing that. It kind of looks sloppy, makes it kind of dangerous. It's better when you have your hot feeding multiple items. You want to make a joint in the back here and make it up, and you get 2 pigtails off of that joint, and you can power whatever you want off of that. It's a lot cleaner. I'm not good at doing commentary while I'm actually doing the work, but a lot of times also what you're going to see in older buildings and houses that you're not going to have a ground at all. And if you do, it's going to be a bare copper. I forgot to talk about the grounds, but grounds are always green. If it's a new installation, it's always going to be green. And what that does is basically, if you ever have like an arc flash incident, or if you have like a failure in the device, if something's breaking in it, you don't have like just live electricity like touching like metal studs in your house or screws, like making your house like a death trap. What it does is that it forces the electricity to go back to the panel, just because it's also like it's an additional neutral essentially. And that's mainly just to force the breaker to trip so it's not on anymore, and you can get it fixed. And on light switches, you never put grounds on it. You almost never use them. Like in a lot of new installations, like if at the hospital I work at, you put grounds on them, but in a lot of old houses, you just don't even bother doing it. You're not going to get in trouble for not doing it.
So these light switches, it's 2 of the black jacket, the hot wires, and basically the switch is just killing the connection between the 2.
Yes. Yeah. That's pretty much the goal of the switch. And because I have switches powering 2 different sources, I made sure to designate that there was a difference between the 2. Like I have one that has 2 red stripes on it and one that has 1, because it's, in the end, it doesn't really matter, because they're gonna work regardless. But if you care about knowing which one goes where, then that's what I mean. That's what I mean when I say like it's good to label your wires. And also, what I like to do for safety reasons is that I'll take tape after I'm done, and I'll run it around the screws like this, and cover those screws in the side. That way you don't run into any issues where you're jostling the switch or something around, and it touches the box and grounds itself out. So like you don't, yeah. So it's just good practice to do that. Now, you don't usually use these boxes in your house. A lot of times they're going to be made out of like fiberglass and plastic, and they usually have wings on them where when you kind of like a toggle bolt, which is where it lays flat and goes inside the hole, and when you start screwing it down, the toggle flips over and basically pinches it up against the drywall. Also, a lot of time in your house, you're never going to see it, unless you live in like Chicago or something, like you're never going to see pipe in your house for your electric. You're usually working with this stuff called non-metallic cable. They also call it Romex. It's usually like yellow or orange or brown, but it's still, the wires are still labeled different colors inside that jacket. But it's also like what you're going to be pulling through your wall if you want to have like a new circuit in your house or something. So Now, I didn't really check to see if these are compatible with this cover. Sorry, the other cover. They do the same thing, but if they don't, I can fix that after the video. But that's pretty much how you have these wired up. Now, plugs are a little different. Let me find my plug. In that you run the neutral to it as well as the hot. And these are also very simple. Since this is like a brand new one, this is what I was talking about, where you have spots in the back where you can just stick it in there. You still have to tighten the screw down, but it's a lot easier. Now, what's special about this is that it's a GFI, and what matters with GFIs when you're wiring them is you have to make sure that you're putting it in on the line side of the plug. The line side is the side that the power comes from, because there's a device inside a GFI where if it reads like a connection issue on the neutral side, it's basically got like a tiny little relay in it, and if it's picking up a voltage difference on the neutral side of the wire, it trips itself out, it turns itself off. It's what you see in your kitchen all the time, usually in places where you have like a lot of moisture in the air, like in a kitchen or in a bathroom. That's where you put it. I'm putting one here because they're using it as an outdoor plug, which means that they're going to have something that might be getting dragged in the mud, dragged in some water. But it's a good idea for like any plug you have outside to be a GFCI, unless it's on a GFCI breaker. That's like a whole other thing. Because this is just a stab in, I don't have to make the hook on it. Just check it. I need to trim that down a little bit. Now, the bottom side of the GFI, what that does essentially is if you feed is that you can wire a plug down the line from this GFCI, and that makes that plug and every plug after it protected by the GFCI. And you'll know if you wire it wrong, because if you try to run power through the load side, it's just not going to work. It won't trip on. I can figure out what I just did to my strippers. I got another pair. I'm bad about losing my tools.
So Matt, this GFI has a T, right? Why is that significant? The T, yeah.
That is, okay, that's a good question actually. On a lot of these plugs, you can actually tell which terminal is going to be the neutral and which one's not. The neutral is usually the bigger, more complicated looking plug. Even on like a normal plug, the neutral is usually a bit longer than the hot. That just makes it a little bit harder to break the connection to the plug. That's also like this right here, that's for the ground, if you're using like a 3-prong thing. But that cross specifically is for 20 amp cables. You don't usually run into those very often, but like they do have special cables for 20 amp circuits, and they have the neutral flip sideways, and that's what that's for.
Can I ask why would some machines prefer to have that rear neutral?
Well, the difference is like if, like a lot of times, a lot of the circuits in your house are going to be 15 amps, but there are some things where they need additional ampacity, which is kind of like the volume, of the electricity coming into the device. It's like electricity, weirdly enough, kind of acts like water a little bit, like in a pipe. But I can't remember the details off the top of my head, but like there are some devices that need additional amperage. Like a microwave needs more amperage than like a light or a fan.
Dishwashers.
Yeah, dishwashers are usually even more than that. They're usually like 30.
Dedicated.
They need dedicated circuits, but that's getting ahead of us. Here. Also, what I'm doing right now, it's good to make that you make absolutely sure that your circuit's off, and that nobody's going to mess with it, because this is a really good way to shock yourself. I had a coworker almost knock me off a ladder because I was doing this, and he turned the power on. Oh yeah, I forgot to do the ground. GFCIs usually need grounds. Because grounds aren't as common, if you don't have a ground in a box or you're installing a GFI, a good thing to do is to buy, we call them stingers at work, but they're a prefabricated ground that has a screw on it, and you find a spot in the back of your box, if it's a metal box, and you should try to, like, if you screw it to the box, that usually counts as grounding.
Like the electric ones?
Yeah, like the box that the plug's in.
Oh, okay. What if it's for like plastic?
That's a good question. It's usually, it's not the end of the world if it's not. Like there's usually somewhere along that line it's grounded. It'll go back straight back to the panel. When you're in commercial settings like this, you usually want them in every box because every box is metal, and the actual like conduit itself acts as part of the grounding system, because you have a direct metal to metal connection all the way back to the panel on top of the wire. It's just more redundancy.
Would it cause the GFCI to not work if they didn't have a ground?
I'm pretty sure I've had GFCIs have problems with it. It's been a long time since I've done like residential work, but I would have, from what I remember, I think it did cause problems, but I can clarify that on like some documents and stuff.
Now, installing those stingers that you called, would that be like the last resort? Like, does it matter if you were to install?
That's mainly also just to like if you ever get your house inspected, to get the inspector to like get off your back a little bit. Like he sees that it's grounded, they're usually not going to look too much further into it.
But quality-wise, does it matter if you have a ground wire or if you install a stinger?
I just did that for no reason. I mainly just do it for redundancy.
Gotcha.
It's good practice to have it grounded everywhere you can hope to ground it. Now, another good thing to know about GFCIs is that you don't want your GFCI to be powering something that has a motor to it or a heating element to it, because, which is why you're never going to see a fridge that's been installed correctly have a GFCI behind it, because that's also just that's a really difficult place to fix a GFCI if it trips. But if it has like a condenser or a motor on it, you usually don't want to.
What about a hairdryer in the bathroom? Is that a heating element?
Well, I mean, that's kind of just that's just part of the bathroom thing. That's mainly why that GFCI is there. But heating out, anything that produces,
like a dryer or something?
yeah, like that causes a big influx in voltage draw. So like that will cause a GFCI to trip. Yeah, which is why I said motors and like air condensers and stuff like that for your AC and stuff, just because there's a motor involved. There's like an initial surge of electricity that uses to get the motor started, and then it drops off, and that fluctuation in voltage and amperage and stuff like that can cause the GFCI to just trip out. Well, that one's pretty much done. I do need to modify this a little bit to get it to fit inside the box. So I think there's a, I'll take this. Maybe you do me a favor and get these screws off of here. Need those. Let's go. Give me a second while I look for some hardware that I lost. I think I'll put it over here. Let me know if you need another screwdriver. Assalamualaikum. Thank you. I do need those screws.
Oh, yeah.
You can just throw them in that little box there. Screw go off too. Yes. Can I get that screwdriver back from you? That should be good. I'm gonna go turn it on. You can follow me now. This device here is just called a. It's a transmitter for my tracer, but it is also like a GFCI tester. And they also just call it plug testers. You just put them in any plug, and it's got a set of different lights. And based off of what's going on with the plug, it'll have different types of lights coming on it. This one gave me 2 yellows, which means it's good. It means it's grounded, means there's the neutrals placed. And what I'm gonna do now is I'm gonna leave it in there, and I'm gonna show you guys how the circuit tracer part of it works. All right, so what that device also does, aside from checking whether or not the plug works, is that the relay also sends back like a pulse through the panel, which this can pick up through like electromagnetic whatever. I'm not an engineer. I just know what it means and what the beeping means. But when you have that on, it'll start beeping like that. And if you get a red, like a solid beep, that usually means that you're right on the right circuit. They also just happen to have this written in marker on the side of it, but you can tell it's working because it just stops beeping altogether. Sometimes what you'll have a problem with in houses is that a lot of receptacles and stuff will share neutrals. And what that means is that you'll have the same neutral going to different plugs and lights, like with different hot circuits going to it. So it's not always going to give you the exact idea of where it's going in the panel. And that's also might be a problem, because if you have two hots on one neutral, if you turn off one of the hots, that neutral still has a load on it, and your ticker is not going to pick up the load on the neutral end. So if you ever like touched the neutral and it still has a hot on it, it's going to zap you real good. Like I've been hit by neutrals before. It's very unpleasant. I can't give you the science as to why it's so much worse on the neutral end than the hot end, but it is. Yeah. But that's pretty much all there is to this thing. There's also attachments you can put to that plug tester that will let you like put on just two, like a hot and a neutral. It's just sticking out like a bare wire. It's got clamps that you can put on there. It's got a like a light bulb screw in piece that plugs into it. It's really good. Like Klein has a lot of really good electrical tools for like homework and stuff like that. But it's I usually use Nipix, but Nipix is like the fancy hand tool part of it. Like, but Klein's very good. A lot of guys in the trade use it. If they make any like electrical tool, it's like electrical related tool. It's a very solid buy.